dual behavior of matter particle. This principle was given by Louis de Broglie, and the principle states that like normal EM radiations, matter particles also shows dual behavior, that is both wave-like as well as particle-like. That this principle sounds very strange when we read out about this principle first time. Like, can we have a particle moving in a wave-like way like this one? That's not possible. We don't see any particle moving like in this way in the wave-like motion. But the Louis de Broglie said, like the EM radiations, like a photon which is having momentum as well as the wavelength, these matter particles will also be having momentum as well as some particular wavelength, and they will be showing both particle as well as a wave-like motion. Later on, this principle was experimentally verified by Germer experiment. Again, it was verified by Thomson experiment. We call it that experiment Davison and Germer experiment. That was again proved by the Thomson. So Davison and Germer experiment is the basic proof of this basic principle, which was actually given by Louis de Broglie, who said the matter particles also shows dual behavior. He also said that their wave, the particles wave, or it can be called matter wave, will have a particular wavelength, and the wavelength of these matter particles is inversely proportional to their momentum. The P is here is momentum, and this P is m into v, the mass n into the velocity of the particle. So we write this, and the proportionality is opened by the same Planck's constant, and we can write in place of P the momentum mv. So this is what is the formula which was given by the Louis de Broglie regarding the wavelength of the matter particles, where this m is the mass of the particle and v is the velocity of the particle with which it is moving. So this is basically the formula, which is a major formula which changed completely the way we were thinking about the concept of the matter particle. Now, what is most important about this basic principle is that according to this principle, though the particle shows dual behavior, but we are not able to see this dual behavior or a wave-like motion in a normal hour systems. The reason is because this principle is almost insignificant for the matter particles which are actually are very large, or which are actually having size of which is visible to our human eyes. But when we move to the particle size which is smaller than micro, when we reaches to a nano level or to the Armstrong's level, this basic principle becomes very much significant. So what we say is that this principle is very much valid for subatomic particles, for particles which are very, very small, whose masses are very, very small, and that is why this basic principle is mainly applicable for electrons, protons, and other particles. And because of this, we are not able to explain that we have to believe that the electrons in the atoms will not be showing a normal particle-like rotation in the circular path called orbit. They will be moving like what? A wave in the orbits. So that is the major change which were noticed, that this basic principle completely changed the way we were thinking.